Hello everyone, welcome back to the interview series. In this problem, we shall solve this problem longest common substring. The solution to this problem has been discussed in the previous video, but in this video we shall discuss the space optimized solution for this same problem. Okay, so the problem is same. Given two strings x and y, the task is to find the longest common substring of x and y. The input will contain two lines which contain each line contains a string, and strings are contains characters from small a to small z, and we have to print in the output the longest common substring of the given strings, right? If we have multiple solutions, namely we have multiple LCS in the given strings, then we can print any of them. All of them will be valid. The length of the strings goes up to 10 raised to the power 4. So let's better understand the problem statement with an example. So these are the two strings x and y. The longest common substring in these strings is AB. So the answer is 2 because AB has a length of 2. Fine. So let's review the solution which we discussed in the previous video, namely the naive dynamic programming solution, which takes a time space complexity of m cross n. Okay, so in this solution what we did is simply used a DP array of size m cross n, and let's say I is pointing string, and the pointer j is pointing to string y. So here is the pointer. So this loop basically uses the pointer I, and the pointer j is here in the nested loop, so that it says that for each character I have to iterate over all the characters j. Okay, so as to fill this TP array. So let's see how it is working. The first case is that if one of the pointers is 0, it represents that we are standing at some hypothetical index which is left to the starting of the strings. It simply says that we one of the pointers if one of the pointers is pointing to an empty string, okay, then the LCS for that string and any other string which j is pointing to, even if it is empty or non-empty, the answer will always be 0 because the LCS for an empty string and the non-empty string is 0. Okay, so that's why if I is 0 or j is 0, it will be 0, and this will be true for all the columns and for all the rows. Okay, because if I is 0, we are standing here, then no matter what string we take in y, the LCS will always be 0. Okay, so that's how the first rows are computed. The first row and first column are initialized. Let's see that next case, which is if some ith character and jth character are matching. So let's see this example. If this character is matching, then we require the result of LCS for the strings, for substrings x0 to I minus 1 and y0 to j minus 1. Okay, so if I know the results of LCS for these substrings, then I can find the results for the LCS for these LCS of these substrings. Okay, how? Why this is true? Because what I am saying that, let's say the LCS for the substrings x0 to I minus 1, y0 to j minus 1 is L, and the character I and character j matches, then the LCS will increment by 1 because now the longest common substring is ending at character I and character j. Okay, now the last character of the LCS that we are preparing is A. Okay, so that's what this case is saying. Fine here. And if the currently updated value is greater than the result that we have, then we update the result as well. Okay, so this is the second case, and that's why at this position number 1 1 will store 0 plus 1 here, because LCS for this was 0 and now it will become 1. Now the substring, the LCS is ending at character A. So till this index the LCS is A. Okay, let's see the third case. The third case is if the characters are not matching, if the character number I is not matching with the character number J, then the LCS will, the value at that location will be 0. Why? Because no matter what the LCS for previous strings was, it is not ending at character I and character J. Okay, the last character does not corresponding to whatever the character I and J holds because they are different. So that's why for that we are putting 0 at that location. Okay, so let's fill this TP array using the given code. Okay, so this is the final matrix prepared which we have, and the answer for this problem is 2 because this is the longest common substring that we are finding, and we're finding it at location 2 and 2 of the string x and location 2 or index 2 of the string y if we are considering one based indexing. So this is the LCS AB. Fine. So let's see the optimizations now. If you understood this, then you will. Okay, so let's discuss the optimization which we talked earlier, and the space optimization. Notice that to find the results of ith row, I require the results of I minus 1th row. Okay, so to find the results of I, require the results of I minus 1th row, and I do not have to bother about the results at these locations I minus 2, I minus 3, and so on. Fine, that's all I require, the results of the previous row. So to find the results of row number 1, I require the results of row number 0. Then to find the results of row number 2, I require the results at row number 1. Okay, so here what I can do, I can simply use a matrix of 2 rows. So the dimensions are 2 cross m now. Why? Because the results of the row number 2 here will be stored at row number 0 here. That's all. And for row number 3, I will store the results at row number 1. In other words, for all the even index rows, I will store the results at row number 0, and for all odd number results or odd number rows, I will store the results at row number 1. That's all. And that's the optimization which I am going to make. So here I'm using an array of dimensions 2 cross n is the length of string y, and what I am changing is here. So this is the code, this is the implementation for the optimization which I made here, and let's see how this is helping. I will store the results of row number 2 in row number 0 and row number 4, 6, 8, and so on in the same row number 0. And for odd number rows 3, 5, 7, I will store those results in row number 1. Okay, so if I is even, then I modulo 2 will give me 0. Okay, and I minus 1 modulo 2 will give me 1. So that's the idea I'm implementing here. To find the results of odd number rows, I require the results of even number rows. So to find the results at this row, if I modulo 2 will be 0, which I will store here, I require the results of I minus 1 modulo 2, which is 1, namely the results of this row. Okay, So instead of putting those results in a new row, I will put them in this row. So that's why I am doing I modulo 2 here. Fine. And this will reverse, this will switch in case of I is odd. In that case, I modulo 2 will give me 1 and I minus 1 modulo 2 will give me 0. That means if I is odd, the results will be stored at first row here, and it will require the the uh, results of the row number 0 here. So that's what changes I have made. This will reduce the this will reduce the space complexity by a factor of m. Fine. So this is the optimization which I had for this problem. Okay, rest stays the same, and that's all from my side. And let me show you the code implementation for this solution. So this is the implementation in Python, this is the implementation in Java language, and this is the implementation in C++. Okay, so I have attached the codes in the description, so make sure to check it out and also give me the feedback in the comments. Thank you so much.